Hello everyone, welcome back to the another session in Design and Analysis of Algorithms. The topic name is 0 by 1 Knapsack problem using branch and bound. This topic you will find in third unit as topic number 13. Right, so as far as this video is concerned, we'll be going to talk about what is 0 by 1 Knapsack problem. So with the previous experience of other videos, we are very much aware of what is 0 by 1 knapsack problem. That was placing the items into a knapsack where the weight has to be balanced, the profit has to be maximum, right? So the same problem we were solved using greedy method, brute force approach, dynamic programming, and even backtracking. So we were already find the solution for this problem using these kind of approaches. Now how branch and bound is differs to find the solution for 0 by 1 knapsack problem, that we'll discuss in this video. And also we will be going to generate a state space tree with the bounding function, and so in the previous video we were discussed very clearly that state space tree will get constructed or will get generated using three strategies. The one is FIFO and the LIFO and least cost branch and bound. FIFO branch and bound, LIFO branch and bound, least cost branch and bound. Now I am going to use least cost branch and bound to find a solution for this problem. So you can also use these two things, but as far as syllabus is concerned, I am going to talk about 0 by 1 knapsack problem, finding the solution using branch and bound and this least cost branch and bound technique. Now let's get started. So 0 by 1 knapsack problem. The objective of this problem is to fill the bags with those objects such that the total weights of the objects included in the bag should be less than or equal to the capacity. Now let's see some example. I'll give some example for this problem. So the example is what? There are 4 objects what I am considering. Now the capacity is m is equal to 15. I have 4 objects to place inside the bag. The profits of each object is correspondingly I wrote 10, 10, 12, 18 and the weights of each item is 2, 4, 6, 9. Now one more important thing is if we are taking any object, then we must take the complete object or don't take it all. So that means no fractional part of object can be placed in inside of the bag. So if let us suppose m is equal to 15. So m is equal to 15 in the sense, so I am taking x1 object into inside of the bag. That means m is 15. Now what is the w1, the weight of the first object? 2. So that means 15 minus 2, I'll get 13. So still 13 more weight, 13 kgs of weight I can utilize for the next place item. So now I'm placing x2 item. If I place x2 item, the total weight of the bag now is what? 13. Now w2 is what? 13 minus w2, 13 minus 4, which is 9. So still 9 kgs I can use. Now I am placing x3 object. So x3, if I place 9 minus 6, it is 3. So now to place this 3 kgs of weight, you will be looking at x4 item, correct? Because you have only 4 items in the problem. So you done with the x1, x2, x3. These are what already available inside of the bag. So to place x4 item, what we will do is, we'll be going to take only 3 kgs out of 18 now, normally. But this approach, this 0 by 1 knapsack problem using branch and bound approach will not take fractional part of weights. Okay, so that is what we have to focus much. Now, so the problem is what? The total profit gain should be maximized. So it is a maximization problem. But in the previous video of branch and bound, we were discussed very clearly that a branch and bound approach is for minimization problems. Now, we were discussed in the previous videos the other methods are maximization problems. That is what greedy method, dynamic programming, backtracking, all are for maximization problem. Now, the problem is maximization problem, but we are not going to use these approaches. Though it is not minimization problem, we are going to approach branch and bound. Now, very simple to understand it is, we can solve only those problems which are minimization. Here, the answer we want in maximization. What we will do is, we will convert the signs of the profits. Let's see. So, in the maximization, I have 38 is my profit. 38 and 32, which will be more maximum, which is the maximum value. So then 32, 38 is the maximum value. Now we'll take this as maximization problem. Now what we'll do in branch and bound to fulfill this constraint of minimization, we'll change the sign of it. Minus 32, minus 38. In these two, which is minimum? Which is minimum? Minus 38 is minimum. Though it is, if it is a maximization, we'll consider 38. If it is a minimization, also you are considering 38. That means we can convert the signs of these profits. Instead of positive, we will make it as a negative weight, negative profit, and can also solve this maximization problem, can be converted into minimization and solve. Then again the result will convert back to maximization, right? So this is how we are going to find the solution for branch and bound problems. 0 by 1 knapsack problem, even traveling salesperson problem also we'll do in the same way. Now as far as this video is concerned, 0 by 1 knapsack problem signs we are going to change to be to fulfill the branch and bound constraint, which is its minimization problem. Now let us see how to solve this problem using branch and bound. Now, so I'm going to generate a state space tree, and here I'll be using LCBB. What do you mean by LCBB? Least cost branch and bound method. So in the previous video of branch and bound, we discussed about there are 3 different strategies to generate a state space tree in branch and bound algorithm. So the first is what? FIFO method. The next is LIFO method. The next is least cost method. So we can take all these 3, but I am going to take least cost one. The reason why I am taking least cost is, it is what the fastest method. It is what the fastest method. That's what I am going to take. If you have a question in the examination, then to take FIFO and to solve 0 by 1 knapsack problem, yes, you can do it. If you have a question with LIFO, that also you can do it. And that is the reason in the previous video of branch and bound, we were taken one problem and solved with these 3 techniques. So you can follow that algorithm techniques to apply over here to find the solution. Now least cost branch and bound is what? I will be exploring that node whose cost is minimum for solving it using branch and bound. For each node in a state space tree, we have to find out upper bound and cost. So we define it as sum of all of the profits. Now the solution for this problem can be written in variable size solution, fixed size solution. Variable size solution in the sense that which are objects I placed in the bag. That means let us see, x1 and x3 is my solution. Then fixed size solution is what? 1, 0, 1, 0. So whichever object is placed in the bag, for that object we'll place it as 1. So this is going to be our solutions. You can use variable size or else you can use fixed size. Now, so I am going to take sets method. That is what fixed size method, fixed size solution. Now I am going to solve this problem in this form of solution using LC branch and bound.